All right, hopefully everyone can hear me. Today we'll be going over our Intro to Pandas and Data Visualization workshop presented by DS3 here at UC San Diego. We'll be going over the very basics of Pandas, data frame manipulation, data cleaning, as well as some basic data visualization to help you guys along the way with any sort of data science related projects you might be having today. You're welcome to follow along if you have access to like a Jupyter notebook or Anaconda installed on your device, but it's totally okay if you're not able to follow along. So yeah, if you have any questions during the presentation, feel free to message in the chat or unmute and speak up, and I can resolve those questions. So let's get started. So what is Pandas? Pandas is a software library written in Python. And it's used for data manipulation and analysis. And it's really, really useful because it has data structures and operations that are really efficient at manipulating any sort of table. So any sort of like, if you've ever seen like an Excel sheet, right? Those are like tables full of data and time series data. And time series sounds like really complicated, but it's just data that follows like progression or a progression of time. So if you think about like the stock market, the stock market is actually time series data because it's a bunch of data that occurs in a series of time. The name pandas is derived from panel data. It actually has no relation to any sort of real pandas. So that's just like a little fun fact. So how do we use pandas? Well, obviously we have to start with importing pandas into our Jupyter notebook. The easiest way to do that is just using the line here, import pandas as PD. You can import it as pandas, but using the alias PD makes it a bit easier for us to type. I've also imported OS, NumPy, Matplatib, and Seaborn. These two we'll cover later when we go over visualization, but NumPy is very useful in conjunction with pandas because a lot of features in pandas use the NumPy arrays and vectorization, which is just a fancy word for column operations. It uses a lot of the NumPy libraries to do operations, so it's definitely useful to import NumPy as well. And OS is just here to help us join the different directories so we can load in our data. And I'll kind of go over that in a second. But the first thing we want to do is we want to actually get our data. So our data is often stored in like tables, and we want to get that table into a notebook. So usually it's stored in one of two formats, but it's possible for it to be stored in other formats as well. And those two formats are CSVs, which stands for comma separated values, and Excel sheets. So any sort of like Excel sheet that you see just using Microsoft Excel or Google Sheets. Preferably, you want to have your data in a CSV file because that's what Pandas is natively used to, and it'll help you with any sort of weird formatting. But Pandas is also able to deal with Excel sheets pretty simply, so I wouldn't worry too much if your data isn't in a CSV. What I have here is just the data set that you guys are working with at Triton Hacks. And what I've done is, since the data is inside a folder, it's easier for us to use the os.path.join function from the OS module to create a file handle or file path that's really simple for our pandas code to read. You can definitely do the typing to get to your file if it's in like a folder, but I think using the os path.join is a lot more simple because you can type in the name of the folder that you want to use and the name of the file inside that folder that you want to pull out. So today we'll be looking at the primary results data in that CSV. So we'll be using this variable here to load in our data. So what you can see here is this is how you actually load in your data. Use the PD or the pandas.read CSV function, and you read the file path that you want to load in. Keep in mind this variable here is just storing the file path that we created earlier. So you might be wondering what this here is. This is called a data frame, and a data frame is essentially any sort of tabular or table data. The variable df often stores a data frame, and it's short for data frame, but you can use any sort of variable to store a data frame. Another good name for this data frame could be like primary underscore results or primaries or something like that. But what you'll see here is our data or our CSV file is now like neatly loaded in this like table here. So you'll see we have the column state, state abbreviation, county, flips, party, candidate votes, and fraction votes. All that data was stored earlier in a CSV, and now it's been like neatly organized in this table below. You also see I use this function called head, and essentially what this function does is it grabs the first 5 entries of our data frame. This is really useful because sometimes our data frame can have like thousands and thousands of entries of data, and you might not want to see all of that data. You might just want to see like, oh, did my data load in correctly, or is this data the right data? Or maybe you just want to see if everything looks right. You don't have to load in the full data set. You can just grab the first 5 entries with the .head function. By default, it grabs 5 entries. I think it can grab up to a total of 40 before it starts to like abbreviate entries. But this is definitely a useful function when you just want to get a glimpse of your data and you don't want to see the full set. A quick way to gather some general insights on your data set in regards to like any sort of statistical measure is using the describe method. So you grab your data frame and you use the .describe method, and what that will do is it will give you some basic like counts, means, standard deviation, your min and max, and your different quartiles for your data. So a heads up is this only works on numerical data because I can't get the I can't get the standard deviation of a candidate's name. That wouldn't really make sense. So it will return all like numerical columns, and it will give you the statistical measures for each one. So this is a very useful function for just getting a general look at your data before you jump in headfirst. So I definitely use it I use it whenever I start my data analysis, just to get a general view of like what my data looks like for the numerical variables. So a really important thing about using Pandas is its features that like allow you to select data and manipulate data. So the first thing we want to do is how can we like select data from a data frame? And there's actually like quite a few ways to do so. And this is because Pandas is very, or Pandas has been built upon a lot. So some features that were implemented in the past ended up staying with Pandas. So now the older methods of indexing or grabbing data still are implemented in Pandas, along with some newer methods that got implemented later on. So here are some examples of how we can grab data from a data frame. These 3 methods here all do exactly the same thing. They output this series of candidates. And a Pandas series is essentially just one column of data from the table. You'll notice I did .head for all these again, so only give me the first 5 entries. But the first way is just calling it the name of the column. You'll notice that if you've indexed with lists in Python before, or if you've indexed with like arrays in Java or any sort of like indexing, all you have to do is put in the name of the column you want to get within square brackets, and it will return that column. Another way to do this is using the ilog function. Ilog is just short for index location. And this first entry here is how many columns you want to grab. So since I want to grab a whole column, I use the colon here to grab the entire column. You could also do like 0 to 4, and that would grab only the first 5 columns, so I wouldn't need to use this head function. But that's what this first entry does. It tells you which rows you want to grab. The second entry here tells you which column you want to grab. So I'm going to grab the second column, right? Because this is a 0 indexed data frame. So I want to grab the second column, so I'm going to put in the 1 here. The last way to do this, and this is due to Pandas having the older implementations, is you can just do the data frame and you can do dot, whatever column you want, and then that will also do the same thing as these 2. So as you can see, those are 3 methods to grab information, and I'll demonstrate a bit more of that in a second. But first, I do want to go over what a data frame is and what a series is. So you'll notice that when you work with ilog and log or any sort of like column or row retrieval, you're going to get a series a lot of the time. As I said earlier, a series is just like a column of data. But another way to think about it is a series is just a one-dimensional array containing information from that row or column. So data frame is like a 2D array, or a 2D array. But a series is just that one-dimensional set of data. Once again, You can select from just getting the column. You can just do the candidate's name and grab the first few entries. You can do it by just calling the dot and then calling the name of the column. I don't really recommend you do this because I think there are like possible errors that could arise from this just because it's an older implementation. But it's good to know that you're able to do it in case you ever see or read someone's code and you're wondering why they're doing this. I do prefer using this most of the time to grab columns just because it's the most simple. And then there's selection by index. This is very useful, but if you want to like get specific rows, but if you're going to grab every single row, once again, I definitely suggest using that first method that we learned at the top of this module. So, okay, let's do some practice. How would you get the name of a candidate who has an entry in the third row? So we want to get the name of a candidate who has an entry in the third row. I'll give you guys like 2 minutes to try and get this, and you can just type in chat or you can just unmute and say the answer. And then we'll just move on to like check out the solution. So anyone wants to give that a shot, you can go ahead. Okay, so we can go over the answer now. And as you can see here, it's pretty simple. You take your data frame and you do .iloc because this time we're asking for a specific location on our data frame. We're not just asking for the entire column. We know that the candidates column is the 5th column, and we know that the third row is going to be index 2 because we're 0 index, so it goes 0, 1, 2. So this is how you grab the name of the candidate at the third row of the candidates column. .iloc versus .loc versus iloc. Both loc and iloc can pull out specific rows, but once again, the big difference with iloc versus loc is iloc can take in an index, or rather it has to take in an index, while loc can take in an index or a name. Here I've used an index for both of them, but you'll notice that if I did .loc, whatever the name of this column is, for example, if I did .loc candidates, it would grab the whole column. So iloc is just using the index, loc is using the name or whatever you want to use to fetch a column or row. As you can see, you can fetch an index by the string name with loc, but iloc, you need the index. You can also select multiple columns by putting each column name into a list. So to fetch multiple columns, what you do is you do df, and you actually put in a list of the columns that you want to grab. And what you'll notice is this returns a data frame. It does not return a series. And once again, this is because a series is a 1D array, while a data frame is a multiple dimensional array. And what you can also see here is if I just plug in a list into a df, a single list, it will actually return a data frame, not a series anymore, even though I'm returning a single column. And that's because if you guys have ever programmed in Java, you'll notice that this is a 2D array, right? This is a list and then another list. So this actually returns a 2D structure, even though you only plugged in one column. Now, one of the most important things with data is cleaning the data. Oftentimes, the data that we get is like really messy, whether it be poorly formatted or full of nulls or missing a ton of values. Cleaning our data is really essential to getting our data into a format that's really usable and that's essentially usable for us. Yeah, a large part of the data science project or the process is cleaning and prepping your data. This is to make sure that your data is usable for like any sort of machine learning model or exploratory data analysis or anything of the sort. So make sure that you always clean your data and like look through your data before you start implementing any sort of model or even just doing any sort of like plotting and exploration. So one of the most important tools for cleaning our data is essentially dropping data. If you have a set of bad data, you don't want to keep it inside your data set. So using the drop function is super useful because you can drop data that might not be too useful, or you might be able to drop data that's redundant. So in this case, I'm going to drop the state abbreviation, which was in the data set earlier, since it's redundant to have both the state and the abbreviation. So what I do is I do df.drop. I do the column that I want to drop. I do axis equals 1. Usually .drop will do the axis of 0, which is the horizontal axis. That's not really useful because there's no state abbreviation on that horizontal axis. So you actually want, it's already dropped here because the code's already run. But if you want to drop a column, you want to switch the axis to the first axis. So it actually goes down each column rather than going across each row. The in place equals true function here just makes it so that we don't have to reset the data frame to itself, and it does it in place. This is really useful just so that you don't have to type like extra code. But if you don't do the in place equals true, you would just do df equals df.drop axis equals 1. So I definitely recommend using the in place equals true function or the parameter just because it makes your life a little bit easier. But if you don't want to do in place and you just want to see what it looks like, that's why the in place is default false, because sometimes you might not want to actually drop the data. You might just want to see what dropping the data does. You can also add a column. What I've done here is I've added a county ID to each of the columns, and this is just the code here is just adding a random number and making it into a string. But yeah, you can add a column pretty simply by just doing df and then the name of the column you want to add, and then a list of the data you want to add, or a dictionary of the data you want to add, or any sort of structure containing multiple entries that correspond with the data. You'll see what I did here is, once again, I just created a random number, turned it into a string, then added a number to the end, and then I did for I in range the length of the columns, because each column will have the same length. So this will create a list that has the same number of entries as my data frame, and it will append this county ID to my data frame. Keep in mind, this is just random data. So in real life, you'll probably have an actual like data set, or you might find more information online that might be pertinent or useful to your data set. So you can add it on to the end of your data frame. You can also rename your columns. So maybe I don't like the name county ID and I want to name it ID instead. So you can do df.rename, and then you use the columns function and pass in a dictionary. And in that dictionary, you take your existing name, which is county ID, and then you put your new name as your second entry. And then you hit in place equals true, and that will rename the column from county ID to just ID. You can also replace data. So maybe in this set, instead of having like Democrat and Republican, I just want to have it be D or R. That's a really simple function as well. All you do is you do .replace, and then you replace the name, or you start with the value you want to replace, and then the value you want to replace it with. So what you'll see here is I've replaced Democrat and Republican with D and R, making it a lot easier for me to essentially like navigate through the party if I wanted to just have a more simple demarcation of like what it is. But a good thing to note is replace doesn't only do it for one column. Replace will look through the entire data frame, and if it sees any instance of Democrat or Republican, so if someone's name was like Democrat Joe or something, like it would replace Democrat Joe with D Joe. So that's something to like keep in mind when you do replace. If you're doing replace of like 0, for example, it would replace the index 0 here as well. So you do want to be careful when using replace, because replace goes on the entire data frame. Replace doesn't just replace within a single column. So dealing with null values is also very important when we're cleaning our data. And dealing with null values, there's a wide variety of ways to deal with them, because it really depends on the context of your data. If you only have like 1 or 2 null values, you can go ahead and drop them. But if you have like 20% of your data missing, and it's pretty like pertinent data, you probably need to find a way to either fill that data, or you want to fill that data, otherwise you can't use the data set, right? So there are some basic ways that we can use to fill our data set, or to fill these null values. And there are other more complicated ways to fill your data, but these are like the basics, and these are probably all you're going to ever use in any sort of beginner project. So you can fill your data with the mean. You can fill it backwards or forwards, which I'll cover in a second, or you can fill them with like whatever you want. So how do you fill null values to begin with? So what I have here is I have a series of null values, and I want to fill these values. What I can do first is I can just do the fill NA function, and that will fill all these NA values with 1. You can fill this using fill NA. I can just plug in whatever I want, and it will give me the result, right? I can also fill using the mean. So what I've done here is I've put in some random values in my series, and I'm going to fill any sort of null values in my series with the mean of the data set. So you'll notice that any value, I think the values here in the middle were all null, but we had 2 values, 2 and 1. And when we took the mean of that, that was 1.5. So we filled the entire middle of the data set with 1.5. Yeah. We can also just get rid of nulls completely. So you'll see that the middle set of our data was just a bunch of null values. So I can just do drop NA, and that will drop all null values. Oftentimes, this is the approach that you should take, because if you add data that biases your data set, that's no better than just dropping that data to begin with. But once again, it really depends on the context of your data and how necessary your data is to whatever you're trying to do. So if you can't drop that data, I definitely recommend using the methods we just described to like fill in data. Here are some useful Panda functions you can apply to your like analysis or any sort of like manipulation to kind of like help you improve how quickly you can manipulate data. So the first one is using conditionals to select your data. So sometimes I might want to select data based on a specific criteria, right? But in order to do that, we have to do something a little fancy with our indexing. So what you'll notice here is I've done data frame, and I've done data frame of the state. So that grabs the state column. I check where it's equal to California, right? And this returns only states or only row entries that have California as a state. What's essentially going on here is we're using a Boolean series. So the df state equals California actually returns this series of falses and trues. I know it doesn't have any trues right now, but that's because I think these states are organized by, I think they're organized by or they're alphabetically organized. So obviously these first entries and these last entries are going to be false because California should be somewhere in the middle. But yeah, it returns a Boolean series, and that Boolean series gets plugged into the df indexing, and it just returns all the true values. You can also select data using multiple conditionals. So what if I want more than one condition to select my data, right? What you do is you do the same thing, and you put parentheses around these 2 conditional statements, and you can use and, or yeah, you can use and or I think also like the jor or the other operator functions. Keep in mind, it's a little different from normal Python. You can't use like and stuff like that. You just have to use the and here. Also, you can't use and, like type in and, because that will cause an error. But what we're doing here is we're grabbing all the counties with votes that are greater than 1,000 in Texas, right? So any county that had greater than 1,000 votes and had the state Texas gets returned to us. So we have an exercise here, and let's pull out all the name of all counties in Florida that have more than 1,000 votes. And what you'll see here is we are grabbing the state where it's Florida and where the number of votes is greater than 1,000. We're plugging it back into the ZIA to get the data frame full of Florida counties with greater than 1,000 votes. And then what I'm doing here is I'm just grabbing the county. And you'll see here are all the counties that are in Florida with greater than 1,000 votes. You'll also notice there's some duplicates here. So maybe each county has like a separate primary or multiple primaries. Here we have another example. We're pulling out all the counties that have less than 1,000 votes and are not in Montana. So I just do where the votes column is less than 1,000 and the state is not equal to Montana. Another thing that's really useful for us is proportions. So what if I want to know the proportion of counties that are like Democratic or Republican, right? This is actually really, really easy to find out because all we have to do is grab the total number of Dems or Republicans in our set, and then divide it over the total number of entries in our data set. So we can do this by summing the number of entries in each column, and then just divide that by the total. So what we can do here is I have these two variables, Dems and Reps, and they contain the number of Democrats and Republicans in each in the data set, essentially. So what we'll see here is if we do df and we do the party equals d, because you'll remember earlier I replaced all Democrats with d and Republicans with r, and I do dot shape 0. What dot shape 0 is, that just gets the like size or like the length. You can also do len and surround this, and it'll do the exact same thing. But these two lines here store the number of Democrats and Republicans in our set. The total is the df.shape 0, which is the same as like I could also do length of the df once again, and I could do the Dems divided by the total number and the Reps divided by the total. You'll see that in our data set, 36% of the entries were Democrats and 63 or 64% of our entries were Republicans. And that might give us some insight on like maybe this data set's like really biased, or maybe this data set is like missing data or something like that. But it's really good to know what proportion we have in our data set as well, just because that's super useful for any sort of analysis we might want to make. Here's another exercise. What's the proportion of counties with over 1,000 votes? What proportion of counties with over 1,000 votes are Republican in Florida? Essentially what we're doing here is we're doing the number of counties that are Republican with greater than 1,000 votes over the total counties in Florida. So what we can do here is grab the total counties in Florida by doing df, the df of the state, and grabbing the shape, which is just a number. Keep in mind, you can also do length of this data frame. It gives you the exact same thing. And then we're grabbing the number of Republicans in Florida where there are greater than 1,000 votes. So we're doing the exact same thing we did earlier, except we're also including that the party should be Republican. Now, if we do that, we divide it by the number of counties, you'll see that 44% of these counties were voted Republican in this primary. Last but not least, we want to apply certain functions to an entire column in a data frame, right? What if I wanted to take some sort of function and apply it to every single entry in that column? This is where the apply function comes in. And what we do is, let's say we want to subtract the mean from the number of votes in each county, right? In order to do that, we first want to create a function. So what I've done here is I've created a Lambda function. You can also create a normal function and plug it into apply. But what I'm doing here is I take the mean number of votes and I create this function called subtract mean. And I use the Lambda function, which is just like a mini function that I'll go over in a second. And I take my mean and I subtract it from x. I then apply my function using the .apply function here, and the column I want to apply my functions to. I created this new column just so that you can see what it does. But when I use the .apply, it takes this function and applies it to every single entry in the votes column. So you'll see the mean votes was like somewhere in the like mid 2000s. So when you subtract it from each one, right, these votes will be negative because this is not a lot of votes, and so on and so forth. So this is what you get back when you apply a function in the votes minus column. Keep in mind, if I just did df votes equals df votes dot apply, this entire column would actually be replaced. Lambda functions are one-line functions. It can take any number of arguments, but it can only have one expression. I like to think about it as like a mini function. So if you have like a very simple function and you don't want to write like a function, you can just do the lambda function. So you lambda x, x is like the thing, your parameter, and then you do x plus 10, and this function will add 10 to every single entry in like a row. You can do the same thing with a function. If I create this function here called do something, and I return x plus 10, does the exact same thing as this lambda function. So this is what you're returning, or this is the operation you're doing, and this is a parameter. You can also set this equal to a variable, like I did here, in subtract mean, and that variable essentially becomes a function. We can also group in the data frame, so we can aggregate data based on a specific category. The tricky part of this is picking how you want to aggregate your information, because if I just do a group by, and I don't pick on what I want to aggregate by, if I don't say, oh, I want to aggregate this on the sum or the number of entries or the count, this will actually cause an issue because it doesn't actually return any information. So the group by function actually returns a group by object, and we need to put a function on that group by object in order to use it. So you'll see here, I group by the party. So the party gives me, if I group by the party and I take the sum, it'll give me the total number of votes that each party received, the number of flips, the sum of the fraction of the votes. This is probably not that useful because fraction votes is a fraction, and I don't want the sum of that. And votes minus, this should be the same because yeah, the number of votes minus, it's the mean. I'm subtracting the mean for each column, so it should be the same. But what's interesting for us is the votes here. We can see the total number of votes for each party. You can also group on multiple columns. So maybe I want to group by party and candidate and then do the sum. So now I can see how many votes like Bernie Sanders got, or how many votes like Donald Trump or Hillary Clinton or anyone else got, right? Based on their party and based on the candidate. You also notice here, it does look like some data is missing, right? Because we have 1, 2, 3, 4, 5 candidates here, but we have like 10 or 12 here. So that's like a good thing to know when you're grouping about like why our data might have more or less entries of a certain type. We could also use our own functions to group everything using the .aggregate. .aggregate basically just takes any sort of, it's like the apply for a group by. So if you have any sort of function that you want to apply, you can use .aggregate on this function and it will return whatever you want to do. I'm just using mp.mean here, but if you had your own function and you did .aggregate, it would aggregate based on that function you created. Last but not least, we have merging. So if I have two tables that have matching information and I want to merge them, I can merge them using the merge function. So what I've done here is I've split up candidates and states into two different data frames, and I'm trying to merge them. So what I'm doing here is I'm merging the states and the candidates. I'm using a left join, which I'll go over in just a moment, and I'm merging on the candidate, right? So since the two tables have a similar candidate column, I can join them together using a left join, and that will give me this like table with the state, county, candidate, and votes. The type of joins or the how is essentially how you merge tables. So an inner join will take in or will only keep the values that are present in both tables. A left join will only keep the values that are present in the left table. So if there's a value in the right table that matches this thing we joined on, so if on the in table 2, let's say there's a bunch of information for Bernie Sanders, and Bernie Sanders is on the left table, but also say in the right table there's a bunch of information for like Hillary Clinton, but there isn't any information for Hillary Clinton on the left table, then Hillary Clinton won't be included in the final table because her information is only on the right table. The right join is the opposite of the left join because it takes anything that's only in the right table and does not include anything on the left table. And then a full outer join just includes everything. So it just combines the two tables together. That's all for our Pandas demonstrations. I will be including a link to these notebooks so that you can reference any sort of code that you might want to use at the end of this presentation. But we want to quickly go over some data visualization. So let's go and dive right in. So for data visualization, you have 3 methods of plotting your data. So you have Matplatib, which is like your basic plotting library. It's a low-level plotting library built on NumPy, and you can use it directly when you need to. You can use .plot, which is Pandas like built-in plotting. It also is built on Matplatib, so it does the same thing as Matplatib, but it's a little easier since it's already included with Pandas. And then Seaborn is like Matplatib on steroids. It's like really like pretty graphing. If you ever used R, it's really similar to ggplot. R is like a statistical programming language, and it makes common statistical plots like really easy. So Here I have some links to all the documentation for plotting, because I think having that documentation is super useful in case you ever forget how to plot something. But yeah, I'm importing all the stuff that we need to plot. I'm also using this magic command for displaying the plots in the notebook. The %sign matplotlib inline, that just means that the plots will be displayed inline. So plotting in pandas is as easy as using .plot. So let's say I have a series here that I want to plot, right? So I have this data frame, and it's just full of like points for me to plot. So yeah, let's say I want to grab the column Z0. You'll see Z0 here. Those are the values in Z0. I can use a line plot to plot numeric data, or I can just do a .plot to plot a line plot by default. The x-axis is the index, and we can call it out using the keyword argument x. So here I'm plotting all those z values. You'll see it gives me this like squiggly line plot. And I can also I can set the index of my plot to the correct x-axis. So maybe I want to set the index of the data x, right? Because in our data, we know that z isn't our x value, x is our x value, right? So we can set our index in our plot using the set_index function, and then we can .loc all the x values that correspond with z0. So these are all the x values, right? And these are all the z values. And we can plot this again, and you'll see that this time the x values at the bottom here are correct, and the y values here are the z values that we found earlier. So when we want to plot quantitative empirical distributions in pandas, we use the keyword argument kind. The hist keyword, we use the word kind. The hist keyword by default uses 10 bins and returns counts of observations. So when you plot histograms, you might want to change the number of bins that you use. And density equals true returns a histogram with area normalized to 1. So it's a little easier for me to show you when I just show you an example of code. But here is that Z0 we have again, and we plot it. The kind of plot we want is a histogram, so we use the hist. We want density equals true, just to kind of normalize it a bit. And we want the bins to be 20 because we want 20 bins, or I think we said 25, but I end up using 20. So here's like 20 bins for your histogram. You can change your bins accordingly, but here's how you would plot a histogram. You can also do like different types of plotting using the kind function or the kind parameter. So this is a kernel density estimate. It shows the same trends as your histogram here, but it kind of smooths it out. So you can say like a general trend here. So yeah, this is like another type of plotting we can do within the pandas plot. You can also do box plots, right? So if you do kind equals box, we'll see this is the box plot of the Z0 data we had earlier. So yeah, those are some ways to plot quantitative distributions. So that's any sort of like numerical distribution. You can also plot categorical empirical distributions in pandas. So if I create a distribution from a categorical column, like name or ID or something, I might want to use these sorts of plots. So that would be like a bar plot or horizontal bar plot. So if you see here, I created an empirical distribution, which is just the ID, I think. Yeah, because ID is like is a category. It's not even though it's a number, it's still a categorical variable. So what I've done here is I plotted all of these bar graphs using bar h. So once again, I'm using that kind function and I'm plotting a bar h. I can also plot a bar graph. And what I've done here is I've sorted the indexes. So now it's in sorted order, and I plotted a bar graph. So you'll see 0, 1, 2, 3. Here are all the ID numbers, and they are plotted as a bar graph. You can also do a horizontal bar graph, as we saw earlier, by just doing the bar h function. You can also plot a full data frame by just doing .plot at the end of the data frame. You want to set your index before you do this. You want to set your index before you do this because if you don't, it will just use the standard index for plotting. So make sure you set your index to whatever you want your x-axis to be before you plot your data. You'll see here, now we've plotted our data. By setting the index to x, we grab the things we want to plot. and we do dot plot. And now we have our Z0 and our Z1 plotted against the X values. You can also do subplots. So maybe I don't want these two plots to be together. I want them separated. If I do dot subplot, or if I do dot plot and do subplots equals true, it will split these plots into two separate like plots here. So we have the line plot, and then we have the Z1 kind of like squiggly plot. So here's how you like split the plots up if you don't want them stacked on each other. And here we have every single column in the data plotted with the subplots equals true. You'll see these are all the different trends that we have, and we can plot them separately, or if I didn't have a subplots equal true, it would plot them all as one plot. When working with data, scatter plots are super useful for like identifying different sorts of trends. So once again, we can use the kind equals scatter. You need to set the X and Y label, but once you set that, you can kind of get like a scatter plot here, and you'll see like any sort of general trend in your data. This is just random data, so you'll see there's no real trend, but if I have linear data and I plot a scatter plot, that might be useful to see like, oh, we have a linear trend in our data, and we can fit like a line to this. You can also use something called a scatter matrix that will plot like every like distribution possible. So yeah, it's very useful if you want to just see a bunch of like a bunch of plots and see like what your data looks like as a general overview. This is like the dot describe version of plotting, but you'll see a scatter matrix will give us a general plot here. So here's some more like scatter plots that you can kind of see. I just included these in case you wanted to download the notebook and see like some different plots. You can also use the keyword C, and that will just like gradient the scatter plot based on the column you entered for C. So we're gradiating these values based on how high the Z3 value is. I think S equals 50 is just like the size of each dot. You can also pass in other keywords supported by the Matplatib scatter. So you'll see we have a Z0, a Z1, and an S here. S is just like the size of the bubble. So what we're doing here is we're doing a scatter plot, and each value is based on like the size of our bubble. Seaborn is just really fancy plotting. Here's just how you install Seaborn, and here's the documentation. The scatter plot for SNS or Seaborn has some other parameters like hue, size, and style. These help us style our scatter plot a bit more. So you'll see here, including a hue will change the hue based on how like high the ID is. Then here's our X and Y values, and you see here it's a much more descriptive scatter plot that we've plotted here. So definitely use Seaborn if you want like prettier plots. But yeah, the hue here is just essentially like color coding each like point based on the ID. You can also do it based off size. So you'll see again here, like the bigger the ID, the bigger the like dots here. We also have LM plot, which just plots the line of best fit inside of our data. So once you've plotted a scatter plot, you can do LM plot, and it'll just fit this line of best fit. This isn't very useful for our data because our data is like super scattered and random. But if you once again have linear data, LM plot might be super useful for plotting a line of best fit and seeing if you have a linear trend. Laura, I'll answer that question right at the end of this presentation. But yeah, we have distplot, which plots the distribution of a histogram. So remember earlier when we did the KDE, you can ignore this. This is just like a warning. These happen all the time. But if you do distplot, it will actually plot all sorts of distributions as like a general distribution plot. So if you don't want to do a histogram, then a KDE, a kernel density plot, and then a rug plot, you can actually do this all in one. And I can actually zoom out here so you can see the full plot because this giant warning is in the way. So 1 second. Too much. You'll see here we have a rug plot at the bottom, a KDE, and a histogram here for all of our data. Once again, you can do box plots as well. This is just the code for a box plot. And yeah, last but not least, we have Matplotlib, which is like your basic plotting tool. This is really, yeah, this is how you import Matplotlib. I usually import it as plot because that's like the easiest way to access it. Matplotlib has objects called axes, and the axes objects are really useful for customizing how we display our plots. So you'll see here, whenever you plot something with Matplotlib, it gives us this like axes like subplot. We want to actually be able to use this now. So you can create the plot to a variable called ax. This is probably like the best way to do it. I like to like use ax just so I know this is the axes, right? So here I have my data. I say that this ax function. I can get the name of the x-axis. So if I do ax, I get x label. I can get the name of that axis. I can get the y-axis like labels, right? So like the different like ranges of labels. If I do, if I turn this into a list, and I do ax.get y-axis, .get major tickable labels, or major tick labels. I'll include this code in the notebook that I shared with you guys. This might be useful if you want to see like the range of y-axis values. And yeah, you'll see that you can also manipulate the actual plot by using the ax variable. So I can set the x label, I can set the title. It's very similar to like R, if you ever used R, where you can like set different labels using the name or like the stored plot. You can add elements to your axis object, right? So here what I've done is I'm adding a z1 to my plot. So ax equals ax will reset the axis here. And I can plot like different points on my axis and so on and so forth. So just think about the axes objects as like using your plot as like an object, like using your plot and customizing your plot using that variable. You can add a scatter plot to an existing scatter plot, right? If you do ax equals data of the plot, you do your first scatter plot, and then you plot the you plot another scatter plot, and then you use your stored scatter plot to plot on top of that. So that's like another like really cool use of using your scatter plots or using the axis objects. You can plot one axis on top of another. You also have figures, and a figure is basically like a container that holds your object, okay? So think about this as like, if I want to have multiple plots, and it'll make a bit more sense once I show like what it does, but usually when you're making some sort of plot, if you want to have multiple plots, you can do the fig comma axes plots.subplots RNC, and this will give you RNC are basically like the rows and columns that you want for your figure and your axis. So axis has the R rows and T columns, and usually they're empty, and we have to give them data to plot. So as you can see here, I've done fig axes and I've done the subplots, and I've done 1 and 2 for the rows and columns. And you'll see it gives me these 2 empty like plots or canvases that I can start plotting on. This is just some information about like all my like all the information on the subplots. Now I'm going to actually plot on these axes. So what I've done here is the fig size 12,4 is just like the size, like the dimensions of the figure. And what we can do here is I use the data frame here. I set the index to x again, and then I do z0 is equal to the first axis, right? So this axis is a list of axes. So I can plot z0 on this first axis here, and I can plot z1 on the second axis here. So by using the axes and indexing into whatever I want to index on, I can plot different plots on these plots. Yeah, you'll see you can also flip it with the 2-1. And once again, you just plot your axes on these different lists. So this is just really useful if you want to plot multiple axes and be really like customizable with what you plot. That's it for all of our visualization and pandas. I see there's a question in the chat, so I'll quickly answer that. And if you have any other questions, feel free to drop them and I'll try to answer them with like the remaining time we have. Once again, let me quickly grab the link to this presentation. So I'm pasting that in the chat now. For anybody who might want to use any of the code we saw today, because I definitely understand that sometimes like seeing this is like a little hard to remember. So the best practice or use of like pandas or like any sort of plotting is just referencing back to code and seeing how you can apply that code. So for the question in the chat, have I used pandas in my courses for college? Yes, I have used pandas like a ton for my courses in college. It's super useful because I'm a data science major, and pandas is how you clean a lot of data. It's how you organize a lot of data. It's how you make visualizations, and it's how you prep your data for any sort of like machine learning models. You'll see this in our later workshop today, where we start talking about machine learning and like modeling. Having clean data is absolutely essential. and knowing what you want to do with your machine learning model is super useful, or it's also really essential, and it's something that Pandas definitely helps you do. What's the difference between Panda and R? Well, first of all, Pandas is really like simple, and people really like Pandas because it's just in Python, and you can immediately import in data. You can do a lot of things in R as well, but I think the big appeal of Pandas is its ease of use and the fact that it's in Python, because you just immediately take your Pandas data and plug it into like a machine learning model, since Python has so many libraries that are like optimized for machine learning. So they're very similar in terms of like what they're able to do and like what R and Pandas can do for data manipulation. But the big benefit of Pandas is that it's in Python. And for the longest time, people using Python wanted some sort of like data manipulation library that they could use, so they wouldn't have to like manipulate their data in R and then convert that like R data, like that R code into Python, and then like take that code and then put it into like a machine learning pipeline, and then like convert that back to R, right? Like that's just like a really big pain for them. So yeah, a lot of like the big features actually derive themselves from R. A lot of the like data manipulation you saw today actually came from R, but Pandas was created just for like a bit more ease, so people didn't have to like create all these like weird pipelines to get data from one language to another. So that's like the really big difference between Panda and R. I think both are like extremely powerful like tools, and if you know how to use R for like data frame manipulation, that's like great as well, because R also has some features that Pandas doesn't in regards to like any sort of like statistical analysis, because once again, R is like your statistical programming language. So if there's something that you can't do in Pandas, I definitely recommend doing it in R. But if you want to do a lot more machine learning or any sort of modeling, Pandas is definitely the way to go, just because a lot of the features are kind of optimized for the Python machine learning libraries. I hope that was like pretty clear on like why, or like the big difference and the advantages of Pandas versus R. But yeah, if you guys have any more questions, feel free to drop them in the chat. But yeah, I've linked the GitHub in the description, and hopefully the rest of like your hacking goes well this weekend. And yeah, definitely check out the machine learning and modeling workshop that we're hosting. The person hosting that is super experienced in machine learning, and he'll give you like a really good rundown of yeah, like how to use machine learning models and how to apply like the stuff we've learned today into your projects. So yeah, good luck with the rest of your weekend, and thank you for attending today.
Hi everyone. If you haven't checked in yet, I linked the check-in code and the check-in form in the chat, so please check in so you can get credit for it. But thank you, Brian and DS3 for hosting this workshop. Yeah, the recording will be posted later. We're just waiting for Zoom to process it, and it'll take some time to upload it to YouTube, but it will be posted.